In this clip on division, we're going to move on to something rather more complex. That is division of triple digits by double digits. But don't panic, because I'm going to show you an easy way to do it. It's a total breeze. I'll be using estimation. Here's a word problem. 388 students at Genius Academy Junior Public School are going on a trip. The principal needs to order buses. She knows that 54 students can fit on one bus. How many buses does she need in order to transport everyone? Well, in a lot of the earlier clips we used the chunking strategy. And guess what? The chunking strategy relies on estimation to a certain degree. So let's begin. We'll do that again. Following the same procedure as last time, I'm going to start by writing 388, that's my students, divided, there's the long line for the chunking strategy, divided by 54. We have 388 students. We need 54 students to fit onto one bus, so we're trying to make equal groups of 54. That's what we're doing. So how am I going to use the chunking strategy in this computation? Agreed, 54 is a pretty unfriendly number. But one thing that's quite easy to do with this number is to double it. Do I think that double 54 will fit into 388? Well, we all know that double 50 is 100, which is way less than 388. So I'm quite confident that double 54 will fit into 388 quite nicely. Let's try it. 2 sets of 54. 2 multiplied by 54 is, well, 2 lots of 50 is 100. 2 lots of 4 is 8. So that makes 108. 2 times 54 is 108. Okay. So I've given away 108 students, or I've put 108 students into buses. 2 buses. So let's subtract. 388 minus 108. That makes 280. Okay. So I have 280 left to share out. 280 students left to fit into buses which each hold 54 students. So we already know that 2 times 54 is 108. That's still less than my remaining 280. So let's try doing the same thing again. I'll give away 2 sets of 54. 2 sets of 54 is 108. I've given them away, so once again I must subtract. 280 minus 108 is 172. Just fix that. 172. Now we're down to 172 students. We can still fit 108 into 172, so let's do it again. So 2 more buses is another 108 students that we can take out of the equation. Just make this a little bit longer. So 172 minus 108 is 64. And how many times do you think 54 goes into 64? Clearly, just once. So here I'm going to write 1. 1 more bus takes care of another 54 students. Let's subtract. 54 minus 64, that's easy, counting by tens. 10 students left. And how many times does 54 go into 10? Ha! It doesn't. Looks like that's a remainder. How many buses have I used so far? Let's count them up. 2, 4, 6, 7. I have 7 buses. I have 7 buses. I have 10 students left over. So the answer to this computation is 7 remainder 10. Is that an acceptable answer in real life? Do these 10 students get left behind? That's pretty unfair. So it would seem that in real life we would need 7 full buses plus 1 more bus to seat the remaining 10 students. Remember that in real life the remainder must be considered. So in this problem, we're going to have to round up our number of buses to give a practical solution, because the principal does need to ensure that all the students can go on the trip. Therefore, the answer to this word problem should be written like this. The principal will need to order 8 buses. 7 will be full, and 1 more bus will be needed to seat the remaining 10 students.